Hi all. So in the last section, we have discussed about how to solve a system of linear equation in three variables using Gaussian elimination method. And in this session, we'll be learning how to solve a system of linear equation in three variables by using LU decomposition method. So before knowing what is LU decomposition, you want to know what is triangular matrices. So here you can see that I have defined two types of matrices. So one is upper triangular matrix U, we denote it by U, and lower triangular matrix capital L. So before studying LU decomposition, you have to know what are these two types of matrices. So the first one is upper triangular matrix U. So here all entries, if the all entries of that matrix below the main diagonal are 0. Like you can see an example here, that is here you have a matrix. So it is a diagonal. So here in the diagonal element is 2, 5, 7, and above that you can see there are numbers which can be 0 or which cannot be 0, whatever. But in below that we have only 0. That is, there is a triangular form upper of the matrix. So this type of matrix is called upper triangular matrix. We denote it by U. The next type is lower triangular matrix. We denote it by L. That is, all entries above the main diagonal are 0. That is the usual definition of a lower triangular matrix. That is, the entries above the diagonal will be 0. So here it is below, it is 0, and it is above, we have 0. So in this method, in LU decomposition, we are using, it is also known as Doolittle's method. Okay, LU decomposition is also known as Doolittle's method. In this, the lower triangle matrix, we represent it like this. That is, the diagonal entries will be 1, 1, 1. So here we mean by lower triangular matrices, the diagonal will be 1, 1, 1, and the entries above the main diagonal will be 0. So this type of matrix we are using for LU decomposition. So remember, here the diagonal entries will be 1, 1, 1, and the other entries above this main diagonal will be 0. So hope you clear with what is upper triangular matrix and what is lower triangular matrix. We denote it by U and L. So let us move to what is LU decomposition. So why we talked about L and U? Why we talked about lower triangular and upper triangular? Because here the method goes like this. We will get a matrix A, and actually we can compose or decompose any matrix A into the multiple of L into U. That is, we can break down a matrix A by L into U. We can write it as L into U. That is, LU decomposition is a method in linear algebra used to factorize or break down a matrix into the product of two similar matrices, that is A equal to L into U. So why we are using this method? We have already studied a method, Gaussian elimination. So that is enough for solving this. So here the reason why we are choosing this LU decomposition is that for computational efficiency, if you are solving the system Ax equal to B for many different vectors B, LU decomposition is much faster. That is, in the previous, in Gaussian elimination, you can see that for one B we have to do all method. But here, if we solve this if we decompose this A into L and U, we can take any B to solve this. So that is the specialty of this method. If we take any B, we can solve this. So you factor A once and then solve for different B values easily. We can use any B values to solve this. I think you will understand that by solving a problem, you will get it. So now just understand that by decomposing this A into L and U, you will be able to use, or you will be able to solve any matrix. If you get any B, you will be able to solve this. So that is the specialty of this LU decomposition method. So here are the steps to do LU decomposition. As I told, it is also called as Doolittle's method. and we are using Doolittle's algorithm to solve this problem. So the first main step is we will get a matrix, a linear equation in three variables, a system of linear equation in three variables like this as usual. And here we are converting this like this. Okay, we are converting it into a equation like a into x equal to b. So here a is the matrix of the coefficient of x, y, z. As you can see, you can look the first equation a1x plus b1y plus e1z equal to d1. So I am taking the coefficients for the first row, that is a1, b1, c1, and the second row, second coefficient a2, b2, c2, and the third coefficient a3, b3, and c3. And I got the matrix, this matrix, and we denote this matrix as A. So capital A is nothing but the matrix of the coefficient of x, y, and z. And the matrix X are denoted by small letter x. Don't be confused with this. This small letter x represent this matrix. Okay, x, y, z. The small letter x represent the matrix x, y, z, which is equal to d1, d2, d3. I am taking this part as a matrix, and we denote it using small letter b. So don't be confused with the xx. Actually, this x represents this x, y, z. All matrix it represents. So I am writing my system of linear equation in three variables into a form like this: ax equal to b. And the next thing I am going to do is, the next step is, I'm taking this A only. Okay, we will solve that later. So I'm taking this A and I'm decomposing it into L into U. So how you can find a lower triangle matrix and a upper triangle matrix which satisfies this. Okay, so next we take the matrix A and decompose it. That is A equal to L into U. So how you can find U and L? So the first thing is, we are going to find upper triangular matrix. That is, we perform Gaussian elimination. As you all are familiar with Gaussian elimination, which we have discussed in our last section. So we perform Gaussian elimination to find U. Similar, right? We can find the Gaussian elimination. We can use the Gaussian elimination, that is row equivalent form, to find U. But we keep a record of our step. The main thing of that is, so the upper matrix is found by, this is simply the row equivalent form of matrix A, what you get after applying Gaussian elimination. And what is lower matrix you get there? Here, this records the multiplier used during the elimination process to create a zero. So I think you will understand that after doing a question, but here I will just explain it, just listen to it. Like when we are doing Gaussian elimination, or when we are converting a matrix into row equivalent form, we will be using constants or multipliers to change the R2 and R1. We will, here I have an example for that. If we change this R2, row 2 to R2 minus M into R1, we are using that row operations to convert this. This M we take and we will write that for the 2-1 position, that ijth position, that is 2 second row first column of the lower matrix will be this M. Okay, so by doing a problem, you will understand the process. But here you just understand the way how we are doing. So the first thing is, we are going to find upper triangular matrix by using row operations. We are like you have already studied, and we are taking the multipliers of that to form the lower matrix. And the third step is, actually we have a equation like this, right? Ax equal to b. So if we want to solve for x, we substitute a with lu. So we already got a equal to lu from the second step. So we are substituting this a to lu. We are substituting this lu into a. So we will get lux equal to b. And we are doing two steps here: forward substitution and backward substitution. So what is forward substitution? We will take this L. So we got two matrices L and U, and I am taking this L and I am taking a vector Y. So the matrix, it's a matrix actually. Y is a matrix. So let it be y1, y2, y3, and Ly equal to B. So I will get what is Y here, and I will substitute that Y here. Okay. in this equation ux equal to y, and I can find what is the value of x. So x is actually the matrix x, y, z. So from here I will find what is x. So like this we will be doing LU decomposition. So I know you are confused here, but after doing a problem it will be very easy to solve this. It is a very easy method, simplest method to find the to solve for x, y, and z. So here I have a problem for you. So let's solve this new system of equation from this. So it is, I am taking a linear equation in three variables: x, y, z equal to 6, x plus 2y plus 3z equal to 40, and x plus 3y plus 2z equal to 13. So it is a very simple matrix. And sorry, not matrix, a very simple linear equation. And here I want to convert this to matrix form, ax equal to b, right? So here you will get a, as I told, a is actually the coefficient of this equation x, y, z. So for first equation it is 1, 1, 1, second equation it is 1, 2, 3, and third equation you can see it is 1, 3, 2. So I got the matrix A, and the matrix B is actually this side, that is 6, 14, 30. So next our mission is to find L and U, which, so find L, find U, and then solve for x. So that is the method we are going through. So first we have to find U and then L, and we will solve for x. So we have A here. Okay, so from here we are solving this. We have to find what is U and what is L. So this is the matrix A, which you already know. It is matrix A. So I am decomposing that to, or I am turning that to upper triangular matrix. So how can we do? You already know it is by Gaussian elimination. That is, we are using row operations here. So I'm taking. So I want to convert this element to 0. That is R2. Changes to R2 minus R1. If I do this 1 minus 1, I will get a 0. So I am doing R2, that changes to R2 minus R1. So I am getting a 0 here. And similarly, I am doing to every element, that is 2 minus 1, we get 1, 3 minus 1, and you get 2. And similarly, I am changing this, the third row first element to 0. So I want to again subtract this R3 minus R1. So that is our operation, which you have already familiar. So 1 minus 1, that is 0, and 2 minus 1, 3 minus 1, that is 2, and 2 minus 1, that is 1. So you got the matrix like this. So here you want to listen here, that is, so here we have the lower triangular. So the lower triangular is in this form. We have to find the elements, these three elements, which I have question mark. So these three elements we have to find. So the first two element, okay, this two, the first element of the second row and the first element of the third row will be the multiplier, which we are multiplying it with the R1 R. So here we are multiplying 1 actually, right? The coefficient is, we are not taking the minus part, we are taking the number only. So here 1, so I wrote that 1 here, and again we are multiplying. So in this question it is 1, so in it is different for different question, and so in R3 also we are getting 1 here, so I am writing that 1 here. Okay, hope you understand that. And the second step is, we want to make this element also 0, right? To make a row equivalent form, we have to make this also 0. So how can I make this 0? By multiplying a 2 to the second row and subtracting it, right? R3 changes to R3 minus 2 into R2. So I got 0 here, and 1 minus 2 into 3, that I got this number here. And so here I am using the multiplier 2. So this is called the multiplier. I am using 2 into R2. So here, so the third unknown element is actually 2, the multiplier. So like that we got U and L simultaneously. So like this we are doing every problem. It is very easy. Like we want to convert this upper matrix A to upper triangular matrix, and by taking only the multipliers you can fill the unknown values of lower triangular matrix. So like that you got U and L. So U is 1 1 1 0 1 2 0 0 minus 3 and L is actually 1 0 0 1 1 0 1 2 1. Okay. Okay. So next I'm doing forward substitution and backward substitution. So the first thing is L into Y equal to B. So you know what is L. Okay, you know what is L. We got what is L. L is actually 1 0 0 1 1 0 1 2 1, and we are instead of Y we are writing a matrix Y1 Y2 Y3. So this is actually the matrix Y, and we know what is B. From first we wrote what is B, that is 6 14 30. So by solving this, we will get what is y1, y2, y3. That is, we will get the matrix y, and we will substitute that here and find the values for x, y, z. So that is the method goes. So here you can multiply this as you know how to multiply two matrices. So it will be y1, and the second row will be y1, y2, and y1 plus y2, and the third one will be y1 plus 2y2 plus y3. Okay, so you will get y1 equal to 6, and y1 is actually 6, so 1 into y1. So instead of y1 we wrote 6, so 1 into 6 plus y2 equal to 14. That is second element. So you get y2 equal to 8 here, and you know what is y2. So 1 into 6 plus 2 into 8 plus y3 equal to 13. So by that you get y3 also. So you got the matrix y 6 8 minus 9, and we substitute that y here, and you know what is u. 1 1 0 2 0 1 2 and 0 0 minus 3 into you got what is x y z, and you have 6 8 minus 9. Similarly we will solve this and we will get the value. So first you want to multiply this row to this column, like very similar, you know matrix multiplication. So x y and z, and here it is 0, so y plus z and 0 0, that is minus 3z. So by comparing this both side you will get minus 3z equal to minus 9, so you get z equal to 3 from here. And the second row is actually y plus 2z equal to 8. When you are comparing both sides you get y plus 2z equal to 8. So you already got what is z. Z is 3, and y plus 2 into 3 equal to 8. So you will get y equal to 2, and in the first row you will get x plus y plus z, which is equal to 6. Actually when you are comparing you will get 6. So by substituting for z and y you will get x plus 2 plus 3 equal to 6, and you will finally get the value of x equal to 1. So you have solved for x, so the x value is 1, y value is 2, and z value is 3 here. So hope you understand what is LU decomposition. It is very easy. It is somewhat similar to Gaussian elimination. So for finding upper triangular matrix, we are using Gaussian elimination method, or the method row equivalent. We are changing A into row equivalent form by using row operations, and from that itself we can find the value of it. So similar like that we are doing this. So hope you understand. Okay, thank you.